Good morning, everyone. I'm Winnie Dong, the professor for this class, Intro to Material Science and Engineering. Hopefully, that's the class you're here for. So I'm going to get started. I will give a brief introduction to myself. My name is Winnie Dong, Professor Dong. And if you could call me Professor Dong, Dr. Dong, or if you want to call me by my Chinese name, Dong is my married name. So my Chinese name, my last name is actually Jiang, as in Changjiang, the Jiang. And so you could call me Jiang 老师 or Jiang 博士. From my education, I received my Bachelor's of Science from UCLA, and then I also received my Master's and PhD, all from UCLA, and in Material Science and Engineering. That's where I met your department chair, Professor Chen, and then also another one of your professors, Dr. Wu Puwei. So that's how I came to be an invited lecturer or professor at Jiao Tong University. And I think Dr. Wu invited me because I got an award for my mentoring in science and engineering from the President of the United States. And I think that's probably why he invited me to come and teach a class. So hopefully I could live up to his expectations of being a good teacher. So since I graduated UCLA in 2000, the year 2000, I have been a professor at Cal Poly Pomona, and it is a state university, part of the California State University system. And it is located in Southern California, about 30 minutes east of Los Angeles, or maybe 45 minutes east of Los Angeles. I don't say miles because in Los Angeles, we measure everything by time. It doesn't matter how far it is. Sometimes it takes a long time to get from one place to another. So I've been teaching at Cal Poly Pomona for 23, I'm entering my 23rd year. So 22 years now, going into my 23rd year. And I started my career at Cal Poly Pomona teaching and doing research in material science and engineering. But over the last 8 years, roughly 8 years, I have transitioned more to leading programs. So I lead many different programs that help students get into a PhD program. I help students do undergraduate research. So if you have questions about the graduate school process in the US, definitely I'm happy to talk with you, not during class time, but in email if you want to meet about that process. If you have questions about undergraduate research, I can certainly tell you what it's like in the US, but I would have to consult your professors here to have a better idea of how that works here. I don't know if undergraduate students do research or if it's just graduate students at Jiao Tong University. I actually grew up in Taiwan, in Hsinchu actually. My father was a professor at Tsinghua, and so I grew up in Hsinchu and went to the US when I was 10 years old. So I finished 4th grade in Taiwan, and so I can speak Chinese. It is limited. So remember, I left when I was in 4th grade, so my Chinese is still stuck in the elementary school level. I certainly can't teach this class in Chinese. I don't know the technical words in Chinese. But if you have a question and you want to ask the question in Chinese, you could do so, and I will do my best to understand and then to respond however much I can in Chinese/English. So that's definitely an option. So let me tell you a little bit about why I chose to study material science. And I'm going to ask you to also tell me a little bit about yourselves. So be ready. You don't have to speak. I'll let you do it online. But I chose material science. Actually, I didn't really know what material science was. After I graduated high school, I applied for material science at UCLA. But once I started taking classes, I realized it was really the perfect major for me. I was really interested in physics and chemistry in high school. And material science for me is a perfect blend of physics, chemistry, and then how to apply what you learn into something practical. And I realized that material science answered a lot of my questions about just how the world works. And I'm hopeful that as you take this class with me, that you will start to see the connection as well between what you learn in this class and what you experience in your everyday life. So for example, actually, just so I know that all of you know how to use Zoom, if you could go down to the bottom of your screen where it has a little smiley face and it says reactions, can everyone give me a thumbs up or a sad face if you want? Thank you. So how many of you have ever considered why glass is transparent? So how come you can see through glass? Give me a thumbs up if that's something you've actually thought about. Okay. And how many of you have ever thought about, well, okay, glass is transparent, but metal, so aluminum, steel, those kinds of things, they're not transparent. Why is that? And then also glass, so glass is usually, not always, but usually is insulating. So it doesn't conduct electricity, right? And then metals, oftentimes, most of the time, will conduct electricity. So those two things are actually linked. So I don't know how many of you have ever thought about that, whether transparency, the optical properties, and the conduction ability or electrical properties are actually linked in materials. So most of the things that are transparent will also be insulating, electrically insulating, and most of the things that are electrically conducting will also be not transparent. And the reason for those things have a lot to do, or everything to do with the structure of materials, with how the atoms inside materials are lined up, how they're bonded to each other, and how they're arranged. And so through this class, we're going to talk about all of those things. We're going to talk about the atomic bonding of materials. We're going to talk about structure. We're going to talk about how that structure can be manipulated or changed by different things that we do to materials. So by heating, by working the material, and by other processes, we could change the structure of the materials. And by changing the structure of the materials, we could also change the properties of the materials, so that it is possible now to have materials that are both transparent and conducting. And it is also, so those are the things that we will talk about. And there are many other things that have to do with how the bonding and the structural materials, optical and electrical properties are just two of the most common ones. But even in just how water behaves, it has to do with, water, usually we think of materials as something solid, but liquid materials are also materials. So how water behaves versus how alcohol behaves, those all have to do with bonding as well. So those are the kinds of things that I will introduce you to in this class. So now I'm going to go over the syllabus with you. So my syllabus, it's basically a contract between me and all of you. It's how I will run my class and what my expectations are for you and how you can earn a grade in the class. And some of you may get an automatic response saying I'm out of the office. That's because I'm not right now at Cal Poly Pomona, but here in Taiwan. So that's what you will get. You could just ignore that automatic response. I talk about my class objectives. Please do read through that. The readings, so the textbook, you should all have it. It's the Callister textbook that's very commonly used all over the world for material science. And the reading, I do expect you to complete the reading before the start of each class. So, and I'll go over where you can find what you're supposed to read on the syllabus. The project, so instead of having homework, you're not going to have any homework in this class, no homework assignments. But before you get too happy, instead of homework, I do have a project assignment. And the project, you will see, we will go over it in more detail tomorrow, is that you will be working in a team of roughly 4 students per team, and you will have quite a bit to do for the project. And I will also give you some time within class to work on the project if you need to. So here, in terms of grading, the project will be worth 30% of your grade, midterm 30%, and final exam 40%. And I grade just on a straight scale, 90 to 100 is an A, 80 to 90 is a B, and so forth. So here's the rough class schedule. Of course, this can change due to how quickly we go through material. So if I go through things more quickly, we might be ahead of the schedule, or we might be behind, hopefully not too much. And the chapters that you will need to read are listed here under the reading. So there's nothing you have to read by tomorrow, but if you want to get a head start, you can start reading chapters 1 and 2. But I do expect you to have read chapters 1, 2, and then chapter 3, sections 1 through 7 by next Thursday. Okay, so that's the reading assignment is listed on the syllabus. I go over the topics. We will have a midterm on October 28th, and then a final exam on December 30th. So now I'm going to start talking a little bit about material science. Right. And so I'm going to lecture in the same way I will lecture in person. So I'm going to pretend this PowerPoint sheet is my whiteboard or my chalkboard, and I'm going to write on it. And then when I'm done, I'm going to erase it. Okay? So it's not, you're not going to get a bunch of notes on this PowerPoint to take home with you. So you have to take your own notes. Just like in person, you would not be taking, I guess, you wouldn't be getting a set of notes from me when I'm teaching in person. So the same thing as online. So I'm just going to write on what you see here, and you'll have to take notes along the way. So what is material science? And why is material science important? And so hopefully I'm going to read in your responses to my survey about why you're taking this class or why you decided to major in materials. But materials have been really important throughout human history. It is what drives human development, or one of the really important things and what drives human development. In the Western culture, and I think in Chinese, the Eastern culture as well, historians tend to define different periods with the materials that people used. So for the very, very beginning, in the beginning of human development, historians refer to that as the Stone Age, right? So the Stone Age is when people were using stones as tools. And maybe they used it as a hammer to break things. Maybe they learned to sharpen it so that they could cut things with a sharp edge of a stone. But that was basically the tools that they had were made of stone. And then after that, humans started to learn how to work with metals. So the Bronze Age is the next time period. And then after that, it is the Iron Age. And I have a question about the textbook. So in the syllabus, hopefully you can all access E3 site for the course. The syllabus is posted under documents, and it talks about the edition, but it's edition 10, the most recent one. I believe the previous editions are also very similar in terms of the chapters. So if you have access to an older edition, I'm pretty sure that's fine. So after the Bronze Age is the Iron Age, and we will talk about what those things are. What is bronze? What is iron? And why are they important? And then in terms of materials today, what materials do you think? So please enter this in the chat. What kind of materials do you think of when you're thinking about driving innovation or technologically advanced things? Okay, silicon, very good. Semiconductors. Carbon fiber. What about glass, right? Glass seems like a very traditional material, but it actually, if you think about fiber optics, a lot of communications are based on glass. Aluminum for lightweight materials. Right, thank you. Thank you for putting your answers in the chat. So now I want you to think about, why is it important to understand materials? So any thoughts about why it might be important to have a better understanding of how materials behave? It's really important to know the difference between one kind of steel with another kind of steel if you're building a bridge, right? Or a tall building. It's important to know why silicon behaves as a semiconductor if you're working on silicon, on semiconductors, then what other kinds of materials you can use besides silicon as a semiconductor or as a LED, a light emitting diode. Lots of different applications. All the things that we use in our daily life has to do with understanding materials, knowing which materials to use, knowing how to make materials behave the way we want them to behave and not in a different way. You know that steel can become brittle, or maybe you don't, but steel can become brittle. So steel is something that's very strong. We use it in a lot of structural applications. It is used in structural applications because it is strong but ductile. That term ductility means that it can bend without breaking. But embrittlement means that steel can become brittle or no longer, it can no longer bend without breaking. So understanding under what conditions steel can become brittle, it's really important so that you're not using steel in a situation where they can become brittle and then lose its structural integrity. And so there are a few things that we will talk about in this class. So the first thing is structure, then processing, and then properties. And we will talk about each one independently, but we will also talk about how they're related, how structure is and processing are related to the properties. So I'm going to erase this board. Does anyone need more time? All right. And so there are several classes of materials. There are metals, polymers, and ceramics. Okay, the basic things. Can you tell me a little bit about what are some of the material properties of metals? And actually, you can all write on the board here. So if you go to the top of your screen, you see, actually, I'm not sure. I think it is the top. So if you just move your mouse to the top of your screen, you should see something called annotate. And if you click on that, you'll see that you can actually write on this board that I'm writing on. So if you can enter, what kind of material properties do you think of when you think about metals? Or maybe you could just enter, if it's too difficult to figure out, maybe you could just enter it into the chat. So what kind of, and I will put it on here for all of us. So metals conduct electricity, can bend. Very good. So that means it's ductile. Can be heated. So it's strong, I would say. Shiny, yes. So if you could think about what things are metals used in because of these different materials, right? They're used as cables for electricity to connect one thing to another. They're used for structural materials because they're strong and can bend without breaking. They're used in certain areas where you need heat resistance, but it is not the highest heat resistance, right? It's not as good as some ceramics are, which we will talk about in a little bit. Okay, so it has some heat resistance. It is shiny. Some of you may know that before people learned how to make really flat glass, people used metals as a mirror, right? Because it has high reflectivity. Okay, and so all of those things that you're talking about are related, and we will talk about why. Conducting electricity, ductility, heat resistance, strength, being shiny are all related to how metals are bonded, the atoms are bonded, and how those atoms are arranged inside the material. Okay, so now polymers. If you can list in the chat some of the properties that you think of when you think of polymers. Okay, very ductile, can bend a lot, or stretchy, I guess. Has low heat resistance, right? Anything else you could think of? I know plastics have a really bad name, plastics, because of its environmental impact. But actually, polymers and plastics are really important in our everyday life, right? So it's cheap, definitely. Inexpensive to produce. Actually, it's fairly chemical. It can be chemical resistant, so it doesn't react. It can, like metals probably are quite reactive if you're trying to store certain materials. So sometimes you need to have plastic bottles. So if you could think of all the things that you use that use polymers. So the cell phone that you have, the computers that you have, there are many, many parts that are plastic, right? So not all of it is plastic. A lot of it is metal and ceramic, but definitely some parts are plastic. They're disposable. I am not familiar, or I don't really understand the term orderly permutations. If you could explain that in the chat a little bit. But so if you could think about all the things that polymers are used in, the chair that you're sitting on, right? So if you didn't have plastics, what would they be made of instead? Because plastic is a fairly new material in terms of human history. It wasn't really developed or widely available until the early 1900s, sorted in a specific order, okay? So what would you use instead of plastics? Let's say you went to go give blood, or you had to go into the hospital and needed an IV, intravenous drip or something for you're dehydrated. And the tube that connects the IV to the needle is plastic, right? What would the hospital be using if they couldn't use plastics, you think? Any guesses in the chat? Plant fiber, very inventive. I don't think that's what they use though, because of the ability to disinfect, to keep clean and to keep sterile. Okay, glass is correct. So if you can imagine that, and the reason why they probably didn't use metals is because of its reactivity to certain things. So it could be metal, but a lot of times it would need to be glass, and that how much more restrictive it would be to do injection or to do a lot of medical things without the availability of polymers, right? So polymers, even though they're kind of in our everyday life as a plastic fork, those kind of things, cheap, disposable, doesn't seem very important and bad for the environment, actually have quite a lot of really important technical and medical uses in our daily lives. Okay, now let's move to ceramics. So if you could put into the chat properties that you associate with ceramic materials. Brittle, right? So it breaks if you try to bend it. Great, it's a thermal insulator and also an electrical insulator. Yes, very hard surface or scratch resistant. So glass is a class of ceramics. Very good. It can superconduct, not all ceramics, but some ceramics can have superconductivity, yes. Fragile, so not strong. Yeah, thank you for entering those. And so all of these characteristics are also related to how atoms are bonded and arranged inside materials of a ceramic material. So we will also talk about why ceramics behave the way they do and how can we change those properties if we wanted to. And so in terms of chapter 1, that's it for me for chapter 1, and we will go over the different types of properties in this class, and the rest of what I will go over will be in chapter 2. So mainly what I will be covering on Friday, so tomorrow, will be kind of a review of chemistry. So it'll be good if you haven't had chemistry. I don't know when you usually have chemistry in a high school in Taiwan, but if you haven't had chemistry in a couple of years, it might be good to review your chemistry a little bit. Reading chapter 2 will also help. review your chemistry. You'll need to be reminded of the different kinds of bonding, electronic structure, how electrons are arranged around the nucleus. And we will talk about that on Friday.